Hello everyone. In this video, we are going to cover the question count anagrams for me. And yeah, this is the last example which I would be taking for a fixed size window. I hope everyone is very much familiar now with the fixed size sliding window problems. The more you practice, the more you will get into the questions. So now, yeah, let's discuss this question first. We have the question count occurrences of anagrams. The question is we are given a word pat and a text txt, and we need to return the count of occurrences of the anagrams of the word in the text. For example, the text is forx, like let's write down this example. Forxo, okay, and we have fxdofr, and the word we are given is for. So yeah, see the anagrams. Anagrams means that if we jumble the letters of that particular substring, then we will get this string. For example, FOR is an anagram. इसमें तो jumble करने का भी जरूरत नहीं ना, direct match हो रहा है. Okay. So we have ORF as our anagram because once we jumble this, we will get FOR. Okay. We have this OFR as our anagram because once we jumble this, we will get it. And yeah, there is no more anagrams, I think. So what is the answer in this case? In this case, the answer is 3. We have 3 anagrams of FOR in our string. So I hope the question is clear. Now let's see the approach. Like, कैसे पता चलेगा कि इसमें sliding window लगेगा? How to identify that this is the question of sliding window? See, we need to find the anagram of the word, like of the string pat, right? Of this pattern string, we need to find the anagram. What does this imply? ये इसका anagram कितने length के substring में मिलेगा? Just tell me one thing. In what length substring you will get the anagram for pattern? In the length equals to this pattern string, right? So you don't need to check in each and every substring. You only need to check in substring which are of length equals to pattern. I hope the first point is clear. यही है ना कि अगर आपको पैटर्न वर्ड का एनाग्राम इस txt string में ढूंढना है, so you would not be going and checking for each and every substring. You would only be checking for substring which have a length equals to this pattern string length. This is the first point. Okay. Now the second point is that you can't check for each and every letter. Like let's suppose this is a initial string txt. This is the initial string txt, and you have a pattern. Let's suppose pattern string, and let's suppose this is like pattern string length. Okay. So if you check for this string, let's suppose. Now if you go and check again for this string and traverse for each and every character, then that is completely like it is going to give you TLE, right? You checked for this string, now you are checking for this string again. So you are having an overlap over here, right? ये overlap हो रहा है ना, इसको किसी तरीके से हटाना होगा इस overlap को. कैसे हटाएं? Like you can use this information. How can you use? You have this pattern and now you need to check for this pattern. So you only need to shift your starting element over here, remove the contribution of this and add the contribution of this. This is the case, right? So yeah, this is a fixed size sliding window. Like the size of window is fixed. Why it is fixed? Because you only need to find the anagrams of this pattern string and nothing else. So yeah, the size of window is fixed. So let's see the approach now, how we can do that. Like ये तो पता चल गया कि ये sliding window का ही question है. This is clear, right? Now how you can solve this? See, let's take that string forx6 and fxdofr. Now just tell me one thing. There are like how many English alphabets? There are 26, isn't it? So what you can do is, like this is a very simple approach. This is a very useful approach for counting the frequencies of characters. And you are going to use it many a times in many different types of questions when you solve the questions related to English lowercase letters. Whenever you are given that the string consists of only lowercase letters and you need to find out the frequency, Yeah, this is one of the approach which you always follow. What we do is we maintain a vector of size 26 because we know that our lowercase letters are 26, and let 0 index denote character A, 1 index denote character B, and so on up to index 25 will denote character Z. Initially all values are 0. Okay. Now, whenever we find A in our string, what we will do, we will just increment this index. If we find, let's suppose we find C, we will increment this index. We find C, again we will increment this index. So what this vector stores? This 26 size vector stores the frequency of lowercase letters. This is like one of the approach for storing the frequency. Yes, you can use map, but yeah, when it comes to lowercase letters, it's very beneficial to use this 26 size vector. It's very beneficial. Like you will use it in many questions. So yeah, you can follow. I am discussing with this approach so that you also get to learn this approach, this creating vector of 26 size and counting frequency from here. Okay, why we are able to do this? Because we are given that only we have 26 lowercase letters in our string, so no problem of doing this kind of stuff. Now what we can do? We have a pattern string with us, right? We have a pattern string with us. So for that pattern string, we can create a vector of size, sorry. So for pattern string, what we can do is, we can create a vector of size 26, and whichever letters appear how many times we can store in that this 26 size vector. For example, for fox, what we can do is we can increment the count the value of create the value of f as 1, o as 1, and let's suppose x as 1. F as 1, o as 1, and x as 1. We can do this. Okay. Now while traversing over the string txt, we will have a different vector. Okay, we will have a different vector of size 26. Let's call it a temporary vector. Over here also we have all values initialized to 0. Like all values are 0. Okay. And so on. So whenever you come to any index j and you want to store its contribution, so what you will do? You will increment the value of this character at this particular array. Okay. Now once you have a window size of k, what you can do is you can check if the if the pattern vector and the temporary vector are same. This means that in this k size window, the count of the letters which came in pattern window, they're exactly the same that came in this temporary window, like this window of size k. So you can say, yeah, this is one of the anagrams possible. So you will just increment your count. You need to tell the total count of anagrams. So you will increment the count. If not clear, just see this once. Okay. Let's suppose you have a string. For example, in this you have FORXX, FORFOD. Let's suppose this is a string given to you. Now what you can do is, you have and you have a pattern FOR. And in the pattern, you have, let's suppose take a string something different so that it gets more clear to you. Let's suppose we have a pattern as ABC and your text string is, let's suppose it's ABCCBA, CABB. Okay, let's suppose this is the string. So what you will do, you will have a pattern vector. In pattern vector of size 26, all values will be 0 instead of values of ABC. Isn't it? The value of A will be 1 because A occurred one time. The value of B will be 1 because B occurred one time. And the value of C will be 1 because C occurred one time. Isn't it? And rest all the values will be 0. Okay. All the values till Z will be 0. Now, when you come to txt vector, for txt vector, we are like for txt string, we are maintaining a temp vector. And initially, all the values in this temp vector are 0. Okay. Initially, all the values in this temp vector are 0, and so on. Now, when you start from here, I is 0 and your j is also 0. Now, you come to this index j. You want to note down the contribution of this. So its value is A. So you will just increment your count of A. A becomes 1. Now you check that window size is K. Is window size K? How you will get the window size? The window size is exactly equal to this pattern size. Like over there, they have not mentioned the window size directly, but you know that window size will be equal to the size of this pattern string because it can't be greater than that. It can't be more than that. मतलब हम लोग को अगर ऐसा सब स्ट्रिंग चाहिए जिसको जंबल करने पर यही स्ट्रिंग आ जाए, देन वो जो स्ट्रिंग होगा उसका साइज एग्जैक्टली दिस पैटर्न स्ट्रिंग के बराबर होना चाहिए ना कम ना बेसी. सो या दे हैव given us the window size indirectly. Okay. So first of all, we come to J. We note down the contribution of A and we move on to the next index. We note down the contribution of B. We move down to the next index. We note down the contribution of C. Now, once we note down the contribution of C and we check the size of window, it is exactly equals to K. Now, if this is the case, we will compare each and every indices from this pattern vector and this temp vector. And we see, yeah, all are equal, like A ka value 1, B1, C1, B0, E0, F0, rest all are 0 for both the vectors, isn't it? So yeah, this is one of the possible answer. So we will just increment our count with 1. Like initially count was 0, the number of anagrams we got is 0, and we will increment our count. Okay. Now move on to the next index. You move on here. Now once you come here, you note down the contribution of C. This count of C becomes 2. You increment C. Now you check the window size. It is greater than 1. And we know that in a fixed size window size, in the fixed size window, whenever you exceed the window size, you only need to shift your starting value by only 1. So you need to shift your I over here. But before shifting this I, you need to remove the contribution of this ith element. So this ith element was A. So what you will do is you will decrement the value of A and your value of A becomes 0. And you come over here J. You come over here. Now your window size is exactly equals to K. That is the required window size. So you compare this two vectors, temp and pattern. Like this is temp, this is pattern. So when you compare these two vectors, you will not find them equal, right? Because A का value यहाँ 1 है and यहाँ 0 है. So you will not find them equal, isn't it? So once you do this, so you know that this string BCC is not an anagram of your string ABC. So you will just move on to the next index. Once you move on to the next index, you will note down the contribution of B. So the count of B becomes 2. And you know that window size exceeds the value of K. So you need to move your I. But before moving your I, you need to remove the contribution. So the ith index was contributing for B. So you will just decrement your B. Now once you decrement your B, you will shift your I. And once you shift your I, now you will check these two vectors because the window size is exactly equals to K. Once you compare these two vectors, you will not get them equal and you will not increment your count. Now when you move this to the index J over here, you will note down the contribution of A. The contribution of A becomes 1 because it was initially 0. So now when it becomes 1, you check the window size. The window size exceeds the value of K. So you need to remove the contribution of ith element. So while removing, it is C. So yeah, you will decrement the value of C to 1. Like it was 2. So you will decrement by 1. It becomes 1. Now when you check the two vectors, compare the two vectors, you get them equal. This means that this window is an anagram of the string pattern. And so you will just increment your count once again. And this you will do so until you reach your J over here till the end. So yeah, what is the time complexity of this code? The time complexity of this code is you are moving your J from 0 to n, from 0 to n minus 1 actually. And every size, the window size is equals to K. You are comparing these two vectors. Now tell me the size of these two vectors. So these two vectors are of size 26. So the time complexity of this code can be big of n multiplied by 26. So yeah, this will pass the test cases, isn't it? So this is a very useful approach when you talk of like the string contains only lowercase letters and you need to count the frequencies of element. This is a very helpful approach. I would say very much helpful. You're going to use this in many questions after this. So yeah, learn this approach. It's a very good approach and you can apply this in this question also and also the sliding. So yeah, let's code it down once. Like you can have one doubt how this index 0 is coming to A. See, if your character is let's suppose B, and so you should always increment the value of 1 at index. So how you can do that? If you subtract if you subtract A from this character, what's the ASCII value of A? It is 97. And what is the ASCII value of B? It is 98. So 98 minus 97 will result to 1, isn't it? So it will increment the 1 at value. So how you can do that? You can just like if S of J is your a character. So you will just decrement, you will just subtract a. Once you subtract this character a, so this will give you the index at which the index for which this vector contains b. Okay, like for a, we are always going to work in index 0, isn't it? So character a minus character a will always result to 0. Similarly, character b minus character a will result to 1. Character c minus character a will result to 2, isn't it? So this is how you can do this. Let's code it out. Okay. So let's keep the window size. We know the window size is nothing but pattern dot size. So store it in k, and you can make a vector for pattern. Okay. This is of size 26, isn't it? And initially all values are 0. Now what you can do is you can traverse over this pattern string. You can traverse over this. Let me increment this. You can traverse over this pattern string. Let's write like, and just store it frequency in the pattern. So pattern of this pattern string of I minus a. What? How we can find the index? By subtracting character a plus b. Okay. So this is how we can store the frequency of all the characters that are coming in pattern. Now for sliding window, what we can do? We can just store one more vector. Let's name it as temporary vector, which will store the frequency of characters in a particular window VR. It is also of size like 26, and initially all its values are 0. Initially your I is 0 and j is 0. And let's store the size of this txt string in m. And till where the j can go, j can last go up to index m minus 1. So we can keep a check, like we can run the loop while j is less than m. Okay. So now when we come to the jth index, we need to first of all like we need to contribute know its contribution. So while adding its contribution, what we can do, we can store it in temp vector. That temp of s of j minus character a is plus plus. Now we can check that what is the size of window. Now if the size of window is less than the required size of window, so we can just simply increment our j and continue from here. And if this is not the case, we will check that if the size of window exceeds the value. If this is the case, we know that we only need to shift one character, right? For a fixed size sliding window. So we need to shift only one character. So what we do is, first of all, we need to remove the contribution of that ith character. So what we can do, temporary of s of I minus character a is minus minus, and we can increment our. And once we are done with this, we can store our answer in this, let's suppose, answer vector. Once we are done with this, we need to compare these two vectors, temporary and pattern. So we can keep a flag check. Okay. So we can run compare for int I equals to 0, I less than 26, I plus plus. If the two vectors, that is pattern of I, let's not keep it I, let's keep it T, because we are using I, isn't it? Okay. So if pattern of T is equals temporary of T, like if not equal. If at any point if it is not equal, so what we can do, we can change our value of flag to 1 and just break from here. Now we know that after coming out of this loop, if the value of flag is 1, this means that these two vectors are not equal, so we will do nothing. But if the value of flag is not 1, that is the value of flag is 0, in that case we are going to increment our answer. And at the end, what we are going to do, we are going to return our answer. Okay. So I hope this approach is clear. Let's run it. Okay, we have got compilation error. S was not defined. Okay, sorry, we made S of j. It is nothing but txt of j. Okay, let's run it now. We missed J++ over here once again. Okay, we got our answer. Let's submit it. Okay, it passed all the test cases. So yeah, 2 points which you need to note down in this question is, first of all, you learned that how we can count the frequencies of lowercase letters by storing a vector of size 26. And yeah, it is never going to get give you TLE, because let's suppose you are running it n times for every index. So you will even if you run 26 times for every index, it will never give you TLE, right? So this is a very beautiful approach. Like you will use this in many questions. I am telling this again and again, but because I know the importance of this approach. Okay. And the second thing is how you identify that it is a fixed size sliding window. Because you always know that if you are going to find the anagrams of this pattern string, it will always be in a substring of length which is equals to this pattern string size, isn't it? So yeah, these are the 2 points, and we will stop with the questions of fixed size sliding window over here. We will practice some questions afterwards, but after this video, we will start with variable size sliding window. So yeah, till here, you must be clear with fixed size sliding window and practice some questions for it, and rest are same. Okay. So thank you. Meet you in the next video with variable size sliding window.